Welcome to the Tower Focused Learners. I'm your exam tower director for today's simulation, and right now we are tracking a massive, high-stakes target on the radar grid. We're looking at complex numbers, specifically mastering the modulus, argument, and conjugate for the Cambridge Mathematics AS and A-Level 9709 syllabus. Now, why are we treating this like an incoming heavy aircraft right out of the gate? Because this specific topic appears in literally every single examination series. It's an absolute non-negotiable for your success. If you don't know how to guide this onto the runway, your grade is going to crash. So buckle in, because we're going to initialize the radar and get this locked down.
But right off the bat, we have a major paradox that we need to address. Why do students consistently miss easy marks in complex numbers? Seriously, think about it. You might just assume it's because the math itself is way too advanced, or the algebraic calculations are just too heavy. But our source data from the examiner reports reveal something totally different. The dropped marks usually come from misinterpreting complex texts and data rather than a lack of raw math skills. It's like watching two operators at their radar consoles. You've got router Alex, who gets completely bogged down in minor details, creating this infinite holding pattern where they run out of time. And then you've got router Sam, who just clears arguments for landing way too fast without ever verifying the structural safety regulations of the math. Both are going to lose points.
Okay, let's dive into the actual flight manual here. Listen to this direct quote from the Cambridge Academic Benchmarks. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. So what does this actually mean for you in the hot seat? It means the principal examiner reports are actively demanding analytical depth, not just superficial breadth. They want to see that you truly grasp the structural, foundational logic behind the numbers, not just that you know how to blindly plug a value into a formula. You need to understand the whole airspace, not just your specific flight path. Here is the highly structured flight path we are taking today. Section 1, the core concepts complex. Section 2, the procedural framework. Section 3, top 3 examiner warnings. And finally, Section 4, deconstruct, solve, and evaluate. Section 1, the core complex concepts. Let's get these locked in. The entire theoretical architecture of this syllabus rests on extremely precise definitions. Nailing these down from the very beginning is the absolute key to making those cross-topic connections that examiners are desperately looking to reward. First up on the radar is the modulus. Simply put, it is the absolute value or magnitude of a complex number. Visually, it represents its exact distance from the origin on the complex plane. You have to understand this fundamental geometric principle. It's entirely about spatial awareness in your mathematics. The modulus gives you the how far of the equation. It is the exact distance of that radar ping from your control tower. Building directly on that, we have our next essential definition, the argument. This is the angle a complex number makes with a positive real axis in the complex plane. Notice how visually and conceptually the argument pairs perfectly with the modulus. If the modulus gives you the distance, the argument gives you the precise approach factor. It's your heading. Together, distance and direction pinpoint your exact undeniable location on the complex plane.
Finally, we have the conjugate, which is formed simply by changing the sign of the imaginary part of a complex number. Think of it as flipping the vector to its exact mirror reflection on the tarmac. Mastering these three exact definitions, modulus, argument, and conjugate, is precisely what builds the robust theoretical architecture the examiners require. It proves to them that you don't just know the definitions, but you understand the causal relationships between them.
Now, I know what it's like when the clock is ticking down, the pressure is on, and your exam anxiety spikes. To help you lock this in under extreme pressure, here is an insider memory hack. It's your pre-flight checklist. Just remember the first letters, M, A, C. Modulus, argument, conjugate, MAC. When you sit down for that paper and your mind goes blank, just remember to check your MAC. It guarantees you will never leave out a critical, point-scoring component of a complex number analysis when you are routing your approach.
Section 2, the procedural framework. Let's look at how we actually route the approach vector.
Now we are shifting from what the math is to exactly how you process it under fire. The syllabus explicitly requires a systematic sequence for complex problem solving. It is never, ever enough to just know the definitions. You have to know how to sequence them step by step to maximize your point yield. Here is the exact standardized sequence you need. Step 1, deconstruct the question. Step 2, extract the relevant data from the text. Step 3, select your analytical framework. Step 4, execute your analysis with clear notation. And Step 5, present with correct terminology. This flawless step-by-step flow ensures you extract the right information and execute with perfect, undeniable clarity. It's about keeping the aircraft on a smooth glide slope.
Why is strictly adhering to this framework so vital? Well, it all comes down to what I call the fuel to mark budget formula, or in examiner terms, the method mark strategy. In the Cambridge 9709 syllabus, marks are heavily awarded for the process itself. If you strictly follow the 5-step procedural framework we just mapped out, you actively secure method marks at every single step of the way. This means even if your final calculation slips up due to exam nerves, even if the landing is a little bumpy, your structured working out still captures the vast majority of the available points. You don't lose the whole payload just because of a minor arithmetic error at the very end.
Section 3. Top 3 Examiner Warnings. Let's look at the debris on the runway.
Let's shift focus to some direct Amber Alert warnings pulled straight from the principal examiner reports. These reports are absolute goldmines because they tell us exactly what causes candidates to crash and burn. The top 3 mistakes are 1. Forgetting the proper format, 2. Failing to check presentation, and 3. Providing answers that are totally not specific to the given context. These 3 critical errors are the primary reason students leak easy marks. And notice something really important here. They are completely independent of their actual mathematical abilities. It's entirely about execution, situational awareness, and discipline.
All right, tower transmission check. Before we clear this response for final touchdown, I need to ensure your transponder is updated. If you are finding this simulation helpful, hit pause, subscribe to Ace the Exams at Ace the Exams right now, and turn on all notifications so you never miss an approach vector. Okay, returning to the radar. Consider this an examiner alert. On one side, we see confused terminology and vague descriptions. This is Router Alex getting totally lost and dropping marks. On the other side, we have the precise, examiner-approved format where terms are clearly defined. When you hit a structural block mid-paragraph, you need to deploy something like the Peel formatting template, point, evidence, explanation, link, to guide your sentence back onto the glide slope. You must always explicitly define your terms before using them in any extended responses.
Section 4. Deconstruct, solve, and evaluate. Time for the Interactive Runway Workshop.
Welcome to the Interactive Runway Workshop. This final section highlights exactly how top-scoring candidates separate themselves by genuinely evaluating the problem. It's moving beyond just doing the math to active, real-time critical analysis. Here is the core loop. Step 1. Identify the given information. Step 2. Break the problem down into logical steps. Step 3. Solve systematically. Step 4. Check for reasonableness. Does your answer actually make sense in the real world? Or is your aircraft suddenly flying at Mach 10 underground? And Step 5. Make justified recommendations based on evidence. Imagine a 60-second visual timer on a complex source chart. Your job is to isolate the primary trend variable instantly. You need to be able to spot the exact line in a sample answer that violates safety regulations and drops points.
Evaluative thinking maps out distinctly to the person grading your paper. The average candidate stays in superficial breadth. They do the absolute bare minimum just to get by. But the top score pushes into analytical depth. They are questioning assumptions, they are considering different mathematical perspectives within the problem, and they are justifying every single structural decision with hard evidence and crystal clear working. That is the difference between a safe touchdown and skidding off the runway.
I want to leave you with this final, provocative question as we close out this simulation. Are you just solving the math, or are you actively evaluating your assumptions as you go? The difference between those two mindsets is the difference between an average grade and a top-tier result. Apply these frameworks, the Mac memory hack, the fuel to mark budget formula, the method mark strategy, to your past paper practice. Master the modulus, argument, and conjugate by mastering the actual process. Log this as a successful full-mark landing sequence. Keep practicing, stay focused, and before you go, subscribe to Ace the Exams at Ace the Exams, enable that notification bell, and leave a comment below telling me exactly which paper gives you the most anxiety. We'll tackle it together next time. Tower out.